Master slave flip-flop. Most of the timing limitations encountered in the previously examined clock latch circuits can be prevented by using two latch stages in a cascaded configuration. The key operation principle is that the two cascaded stages are activated with opposite clock phases. This configuration is called the master-slave flip-flop. Our definition of flip-flop is designed to distinguish it from latches discussed previously, although they are mostly used interchangeably in the literature. The input latch in figure, called the master, is activated when the clock pulse is high. As you can see in the figure, operation of the JK latch as a toggle switch. Here in this figure, master-slave flip-flop consisting of NAND-based JK latches. During this phase, the inputs J and K allow data to be entered into the flip-flop, and the first stage outputs are set according to the primary inputs. When the clock pulse goes to 0, the master latch becomes inactive and the second stage latch, called the slave, becomes active. The output levels of the flip-flop circuit are determined using this phase. During this second phase, based on the master stage outputs set in the previous phase. Since the master and the slave stages are effectively decoupled from each other with the opposite clocking scheme, the circuit is never transparent. That is, a change occurring in the primary inputs is never reflected directly to the outputs. This very important property clearly separates the master-slave flip-flop from all of the latch circuits examined earlier in the session. Figure shows a simple set of input and output waveforms associated with JK master-slave flip-flop, which can help the reader to read the basic operation principles. Because of the master and the slave stages are decoupled from each other, the circuit allows for toggling when J equal to K equal to 1, but it eliminates the possibility of uncontrolled oscillation since only one stage is active at a given time. A NOR-based alternative realization for the master-slave flip-flop circuit is shown in figure. Here you can see in the figure simple input and output waveforms of the master-slave flip-flop circuit. Figure also shows that the master-slave flip-flop circuit examined here has the potential problem of once catching when the clock pulse is high. A narrow spike or glitch in one of the inputs, for instance, a glitch in the J line or K line, may set or reset the master latch and thus cause an unwanted state transition, which will then be propagated into the slave stage during the following phase. This problem can be eliminated to a large extent by building an edge-triggered master-slave flip-flop, which will be examined in the following session. Here you can see the figure NOR-based realization of the JK master-slave flip-flop. Thank you.